Hi everybody, I want to show you one last strategy you can use for graphing linear equations in two variables. So we've talked about plotting points method, which is basically where you just get to pick values to plug in and then solve for the remaining variable. We've talked about intercepts method, where it is very similar, but specifically you plug in the zeros to find the intercepts of the linear equation and plot those. We've also looked at exceptions, things like vertical and horizontal lines. And now in this last video, I want to talk about how you can use slope to actually graph as well. And we learned about slope in our last video. So a couple of things you want to think about here, just kind of reminders when you're using slope. So if your slope is positive, actually, we'll just call this reminders. Then your line is going to be increasing. And of course, it could look a little different than that. I'm just kind of showing you the general direction. If your slope is negative, so your m is less than 0, the line is going to be decreasing or going down overall. So that's kind of one set of ideas here. Another thing to remember is that slope is the ratio of vertical change, which is the change in y's, to horizontal change. Which are your change in x's. And remember, we can also physically see this on the graph. So when we were talking about slope, we were also showing on the graph how those numbers actually related directly to moving up and down from point to point, right? So you could actually see that change on the graph there. And another quick thing we want to remember is that if the equation is in the form y equals mx plus b, so this is actually called slope intercept form. We can find the slope, which is the m, and y-intercept, which is the 0b, very quickly. And that's really the idea we're going to use here to help us graph, is particularly if we have an equation that is in this form y equals mx plus b, we can find that slope and the y-intercept very, very fast. So why don't we use them to help us graph? Now, if you're not in the form y equals mx plus b, then you could always solve to get into that form if you want to, or you can just use a different strategy to graph, right? You can always use plotting points, you could use intercepts. Even if you're in this form here, you could use plotting points or intercepts as well. So this is just a different strategy that we can use. All right, so I think this is sort of easiest just to hop in with an example here. So we're going to graph y equals 2/3 x plus 1. So notice that we are in that form, right, that y equals form. And this is really when it's most helpful to use this strategy. So we can find our slope right here, and then we can find our b right here. So I know my slope is equal to 2/3. My b is 1, which means that my y-intercept is going to be 0, 1. Now, the other thing you want to notice is that our slope is positive, right? So because it's positive, the line is going to be increasing. So already without even doing really any work, I know a lot about my graph. I know that it has an intercept, a y-intercept at 0, 1. So that's 1 point on the graph. And I already know my slope is 2/3. I see that it's positive. So I know I have some sort of increasing line from left to right. So here's how we can graph using this information. So your first step is going to be to plot the y-intercept. Okay. Now, if you had a different point, so let's say you were doing a different problem and you somehow had a point other than the y-intercept, you could start with that point too. It doesn't really matter which point you start with. So if you had an example on the homework assignment or something like that where you had a different example, then that is fine too, or a different like point to start with. Actually, we'll do this example here. That might make sure I take out my graph paper. So I'm going to start by graphing 0, 1. So 1, 2, 3, 4. I'm going to just do my best to keep my spacing the same. It really should be on my graph paper here. Okay. So my first step is going to be to go ahead and plot that point. Let's do it in green. So I have 0, 1. So I already have 1 point on my graph, which is really nice. And now I'm going to go ahead and use my slope. And you're going to use the slope to find the second point. So 2 things you have to think about. So 1, call it I, is if your m is greater than 0, then you want to remember that you're going to be increasing. And if your m is less than 0, you're going to be decreasing. Now, I'm leaving out when m equals 0 and when m is undefined, because those are our vertical and horizontal lines. So you don't need to do all this to graph those. We can just graph those very quickly like we saw in a previous video. So this is really when your slope is not 0 or not undefined. And the second is that your slope gives you your change in y over change in x. So this is going to tell you the number of places to move in an up and down direction. And your bottom number is going to tell you the number of places to move in a left to right direction, right? Because you're looking at vertical change over horizontal change. So let's look at our particular slope here. I'm going to do kind of my working green. Okay. So this means I'm going to move up and down 2 units, or I'm going to move left to right 3 units. Now, the only thing is you want to think about your general direction. So put this particular problem, since this is greater than 0, we want to make sure we're going in an increasing direction. So we start at this point here, and we're going to count. So if I'm increasing, let's think about this. If it's positive slope, I want to move in an upward direction, right? So if my slope is positive, we're going to go up 2 units from my starting point, 1, 2, and we're going to go over 3 units. I want this to be increasing, so I'm going to move to the right. 1, 2, 3, and that would be my second. Now, what we would do, of course, is take out our ruler here and draw a nice straight line. But that's how we can graph. We do it by counting. And you can check your graph there as well. So if you think about one of the last videos we did, we kind of drew our little triangle, right? We were able to check. So we saw the change of 1, 2, 3 here, and 1, 2 going upward. So we saw that 2/3 change. Okay. So let's just talk one more thing here about direction. Okay. And I think I'm going to have to go to the next page because I'm running out of some. I'm actually just going to take out my graph paper now so I don't forget to use it this time. So when your m is greater than 0, you're going to be increasing. So when you're counting, how do you move on your graph? So what we typically do is we typically move up and to the right, because that will give us that nice increasing line as we go along. Now, sometimes you have to work backwards. So if you need to count backwards, you can do that too. If you were to move down and left, you would actually get still an increasing line. So if you think about here, if I'm starting here, if I go up and to the right, then I'm getting kind of an increasing graph. But if I also go down to the left, I'm still getting an increasing graph because we're always looking, increasing is from left to right. If your m is less than 0, then we're looking at a decreasing line. So how do you do the counting? you're going to count down and to the right, or up and left. Now, the first way I wrote each of those is what we traditionally do, but sometimes if you're kind of running off your paper and you're like, I can't go up anymore, or I can't go to the right anymore, you can always work the other direction. So if I go back to my other graph here for a second, right? We had a positive. So when we're moving, we're going to go up 2 and right 3. So up 2 and right 3, right? That's very natural. And actually, I could keep doing this. Up 2, right 3, and I could keep forming as many points as I want to along this line. But I ran out of room on my graph here. I'm kind of off the grid. So I could work backwards. I could also go down 2. But if I'm going down 2, I have to work backwards as well. So instead of going right, I go left. 1, 2, 3. Okay. And you can see how that line is going to go right through that other point. So overall, we still have an increasing line. And I always have students check at the end. So once you do your counting, because sometimes students make mistakes, look at your picture overall. Is it going the right direction? If it's positive, it should be increasing, right? If it's negative, it should be decreasing. So if you have that flipped, then you know you did something wrong with your counting. Let's do another example. So y equals negative 3/4 x plus 5. I'm in that y equals form, so I can pick out my slope and my b value right away. So my slope here is negative 3/4, and that b value is going to tell me that my y-intercept is 0, 5. So to use this technique for graphing, you always need some point to start. You can't just start wherever you want to. A ton of students will just start at the origin. You can't do that. You have to have a specific point to start on. Okay, so you need the intercept or another point on this line before you can do this. So I have 0, 1, 2, 3, 4, 5. So here's 5. I guess we'll stick with green. So here's 0, 5. And now I'm going to count. So notice that my m is negative 3/4. So I know I should have some sort of decreasing line. So what I'm going to do, I'm going to go down 3, right 4. So again, the top one is your up and down, the bottom is your left to right. And if it's negative, you're decreasing. So we're thinking about going down. We read graphs in general left to right. So that's why you're going to see me draw generally in the right direction. It's just easier. And then I can use that positive or negative to know if I'm going up or down. So I'm going to go down 3, 1, 2, 3, and I'm going to go right 4. 1, 2, 3, 4. And I put my point right there. And I'm going to just repeat this as many times as I want to. Down 3, 1, 2, 3, right 4, 1, 2, 3, and 4. Now, if I wanted to go the other way, I could still do that. So if you want to work backwards, you can. So instead of going down right, you will go up to the left. So I will go, let's see, up 3, 1, 2, 3, and left 4, 1, 2, 3, 4. You can see I'm off the grid here, but I could go in that direction. And then I'm just going to take out some sort of straight edge here. And connect my points. Okay. Again, just double check the overall direction. My slope was negative, so I should have a decreasing line. So it looks like I went in the right direction here. So I feel pretty good about this one. Okay, let's do one more together. All right, 2x minus 7. So here is my m, and here is my b. So my m is 2, and my b is going to give me my y-intercept, which is 0, negative 7. So that minus or that negative stays with the b there. All right, I'm gonna make this graph a little bit longer because I know I have to go down to -7 there. It's +7. It's -7. Let's go to 7 here. And -7. Okay, just to put a few little tick marks kind of on the board here. So when we're graphing using slope, the first thing I need to graph is always my y-intercept. So my y-intercept here is 0, -7. So I'm right down here. And then I do need to use my slope. So I'm just going to do some work a little bit further down. Actually, let's see if I can zoom out a little bit. That's a little better. Okay, so our m here is 2. Now it is definitely positive. So I know I'm going to have some sort of increasing line. Now, if I don't have a denominator, I can always put a 1 there. Okay, so think about if I'm going in the positive direction, I'm going to go up 2, and I'm going to go to the right 1. In general, we always move to the right. That's how we read graphs, from left to right. So that's how I tend to draw as well. But if I have to work backwards, I can do that too. But I try to usually go towards the right. So I'm going to count up to right 1. So I start here, I go up 2, and to the right 1. Up 2, right 1, up 2. And I can do this for as long as I want to. I can keep doing this forever if I want. I obviously don't need this many points, but you kind of get the idea. Now, if I wanted to go backwards, maybe I'm running out of room on the right side. Well, it still works, but you would just reverse it. Instead of going up 2 into the right 1, you would go down 2 into the left 1. And you can see that those points are still lining up and giving us that nice increasing line, which is what we want here. Okay. So there is our line. And again, just give it a quick check. My slope was a +2, so I should see a nice increasing line. My intercept is at -7, which is where I'm crossing. So I feel pretty good here. Hopefully I didn't make any other mistakes, right? But I feel good. I'm going in the right direction. I have that correct point. My starting point is my intercept, and I'm able to graph this, again, pretty quickly. So the strategy works well when we're already in that y = form. If we're not in the y = form, I would probably recommend a different strategy, or you'd have to solve to get in the y = form. Okay, so the big thing to keep in mind that is where students make the most mistakes is just how they're counting. So for increasing, again, you're typically going up to the right, and for decreasing, you're typically going down to the right. Okay, so to the right is our normal direction when we read a graph. If you have to work backwards, then you're going the other ways. But overall, at the end, double check your picture. Make sure it's going in the right direction, which will help you to figure out if you counted correctly as well. So that is our just a third strategy that we can use here when graphing.